Hello viewers, in today's class we are going to solve one important definite integral involving greatest integer function, right? So let us start. So here we have the definite integral from root 2 to root 3 greatest integer x square raised to x, right? So we have to integrate this function f of x, which is greatest integer x square raised to x, and this symbol denotes greatest integer function, right? So in order to evaluate this integral, let us take uh, the help of substitution method. So let us substitute t is equal to x square, right? So when t is equal to x square, it means x is equal to square root of t, right? Okay, now dt over dx is equal to 2x and x is square root of t. So here we have 2 times of square root of t. So therefore dx is equal to dt over 2 times square root of t, right? Okay, now we have changed the variable x to t. So now let us change the limits accordingly. So now here x varies from root 2 to root 3. So when x is root 2, then t is root 2 square, that is 2, and when x is root 3, then t is root 3 square, that is 3, right? So when x varies from root 2 to root 3, then t varies from 2 to 3, right? So now this integral I can be written as integral from t is equal to 2 to 3, and here we have greatest integer t raised to here for x will have square root of t, right? And for dx will have dt over 2 times of square root of t, right? Okay, now to move further, let us make use of the definition of greatest integer function, and here t varies from 2 to 3. So when t lies between 2 and 3, right? When t lies between 2 and 3, then the value of greatest integer t is equal to 2, right? Because by the definition of greatest integer t or greatest integer function, we know that this symbol greatest integer t is equal to greatest integer less than or equal to t, right? For example, suppose we have a number, say 2.3, then greatest integer 2.3 is equal to 2, right? And 2.3, it lies between 2 and 3, right? So when t lies between 2 and 3, the value of greatest integer t is equal to 2. So here we'll substitute 2. So we have integral from 2 to 3. Here we have 2 raised to square root of t dt over 2 times of square root of t, right? Okay, so now this integral 1 is reduced to integral 2. Now let us again make a substitution here, and let us substitute y is equal to square root of t. So dy is equal to 1 over 2 square root of t dt, right? Okay, and when t varies from 2 to 3, then y varies from square root of 2 to square root of 3, right? Because when t is equal to 2, y is equal to square root of 2 when t is equal to 3, y is equal to square root of 3, right? So therefore this integral I reduces to square root of 2 to square root of 3, and this is 2 raised to y, because square root of t is equal to y, and dt over 2 times of square root of t is equal to dy. So here we have dy, right? Okay, so now this integral can be calculated by making use of a standard result, and the result is integral of a raised to x dx is equal to a raised to x over log of a, right? So here we have 2 raised to y, so a is 2, and this integral I can be written as 2 raised to y over log of 2, and the limits are from square root of 2 to square root of 3, right? Okay, so now we can take 1 over log 2 outside, and 2 raised to y, and the limits are from square root of 2 to square root of 3, right? Okay, so now this is 1 over log 2, and if we substitute the values of these two lower and upper limits, and we'll take the difference. So this is 2 raised to root 3 minus 2 raised to square root of 2, right? Okay, so viewers, the value of this integral, that is from square root of 2 to square root of 3, greatest integer x square raised to x dx, is equal to 1 over log of 2 times 2 raised to square root of 3 minus 2 raised to square root of 2, right? So this is how we solve this problem.